midterm project content aware seam carving. In this presentation, we will be covering all the ambiguities faced during this project implementation. The first ambiguity was the energy function ambiguity. The paper did not mention which specific energy function to use, even though even a histogram of gradient was supposed to predict the edges much better. In this paper, in this implementation, I did a Sobel operator by convolving the Sobel operator with the image and trying to get the first and second derivatives. A char function was also used, but there wasn't much difference between these functions, and both these functions yielded more or less the same output. The second problem that I had to face was the seam location insertion. As I kept track of all the seams that were deleted from the image, trying to reinsert them relative to the expanded image was a problem. To get around this problem and working out calculations, found out that trying to update the seams that are located on the right of the current seam by pushing them to 2 pixels would be enough to locate the seams relative to the expanded image. As you can see, due to this assumption, you can see that the expected output was not, the actual output was not in line to the expected output. The expected output was showing more separated seams. However, the actual output, you can see lots of crossovers and the seams are not individually separated. The third ambiguity is the cost of cut ambiguity. The cost of each image pixel was not really specified on what energy function to use. It was assumed that we can use the same energy function from that previous method, and the same energy was used for each pixel. The last ambiguity is the cost of cut in case of an edge issue. So in case of the first column or last column, it was assumed that there would be no neighbors and there was no subtractions done, and the actual energy of the pixel was calculated as a whole. This meant that the cost of the neighboring of the first or last columns and any pixel that leaks out beyond the pixel size of the image would be having a high cost, which meant that when trying to find the seam locating algorithm would skip those pixels which might lie outside of the current pixel. However, if you can see the actual output was not looking like the expected output. In the expected output, you can see more seams carved on the left and last column of the images, but in the actual output, it's spread out. Looking at the final output images, the behavior is not that different, even though you can see little artifacts in the actual output which are not present on the expected output. That's it on this presentation. Thank you.